Hi everyone. This is Anurag Bajpai, and I'm an architect. I have started my journey with Siemens Power, and then worked with the USAID project into energy efficiency and ECBC policy assistance to Bureau of Energy Efficiency. Then I started this organization along with one of my colleague, Adruk Jain, in 2009. This is named as Green Tree Global, which is into diversified areas as of now, but the core is energy as a business. We've been working this area for last 12 years, and we have three verticals to offer. One is energy efficiency advisory services to government, state government, municipalities, central government, and also to the funding agencies. And we work in the buildings, mobility, and air pollution, construction pollution, and other areas as well. The second vertical we have is green building design and certification, and that is where we have been working for almost more than 600 buildings so far, not only in India but across the globe. And the third vertical that we have, which is into education segment, so we into sustainability education domain, and other initiative that we have under Green Tree Global is GT Academy, and this is program is also supported by GT Academy under our umbrella. Thank you, Glass Academy and Ethos, for inviting me here. Ethos is very close to me because I was the first one as one of the team members who participated in Transparency 2006, and we were the winner in that category. And that is where I think I've been very much like following Ethos and Geeta's work in this domain. So congratulations, Ethos and Glass Academy, for doing all the wonderful works for so far, so many years so far. This presentation, when we look at low carbon, net zero, smart buildings, and I'm sure like there are so many acronyms which are there for such energy efficiency or net zero domain. What we understand is that we talk about the same characteristics with the different names. When we look at net zero, it certainly talks about a net zero energy, net zero water, or a net zero waste management practices in a building. In this presentation, I'm primarily focusing on the energy efficiency, so net zero energy building as a subject of this presentation today. And when we look at the net zero energy, it means that we talk about the energy efficiency at different level. And when we look at the energy efficiency, we start with the let's say the minimum efficiency standard, which is energy conservation building code in our country. And we look at the other levels which also have been described by the code itself, that ECBC plus and super ECBC, and that is how we can apparently reach to the highest level of the energy efficiency, which is net zero or net positive in terms of energy efficiency levels for the building. In this presentation, I'm going to talk about energy conservation building code, the scope, technical scopes, compliance options, and etc. I'm also going to touch a little upon residential building energy efficiency code, which is named as Eco-Niwas Sanhita, and then some sort of, let's say, the net zero energy building examples around the globe, and then a very specific case study with respect to the energy efficiency compliance, and also the approach towards the net zero as well. Now, when we look at the net zero, this is a typical building energy use terminology, which is defined by EPI, Energy Performance Index, and it is defined in terms of kilowatt hour per meter square per year. As you can see in terms of the graph, which has the bars, this is a typical, let's say, the building energy performance index that we see for the conventional building. When we look at the ECBC compliant building, then we certainly look at almost 30 to 40% of energy consumption reduction over and above the conventional energy requirement for the building. And then when we look at the Griha and LEED and other these green building rating systems like IGBC, then we certainly look at the more efficient system, because it is not only about the energy they talk about. They talk about water, indoor air quality, waste management, and so many other features which really an important aspects to make the building holistically green and efficient. Then we talk about net zero, because when we look at our India's policy, certainly the policies which have been drafted and implemented across the globe, and fewer of the countries where they have already started this as a policy initiative in terms of developing and building up the net zero facilities. We are seeing the policies from the government and also from the market-based mechanisms initiative in terms of developing more and more net zero energy buildings. And then we look at certainly energy positive buildings or distributed energy resources, or DER, which we see in the developed countries as of now as a business opportunity for the building, not only for the energy consumption but also energy producing entities as well. This is just a summarization of a net zero energy building. What is basically meant thing here, that whatever the energy consumption that building consumes annually, it produces through the renewable energy resources. And certainly, what we also have with, let's say, witnessing, we have witnessed so far that the transport section, that is an integral component of the building design, also gets a lot of support from the recent policies in terms of electric vehicle charging infrastructure and other component which will be certainly be supported by the renewable energy specific domain as well. When we look at the project life cycle, this is an important slide I wanted to highlight, because this talks about uh, the design component, then analysis component, then the construction management, different materials, the technologies, fabrications, and etc. Uh, 3D, 4D, 5D, and etc. All these things, along with the operation and maintenance component of the building. When we design such buildings, let's say, based on the size of the building, if you are designing a 1 lakh square feet building for the tenant purposes or for your own purposes, there is a lot of design interventions which gets changed just because of self-use or tenant-based used building as well. So when we look at your own usage requirement in terms of the building, then certainly a lot of things are very much clear. Then there is no core and shell. There is a new construction, and you have to design everything based on your own usage requirement as well. For example, you have a 1 lakh square feet building. It means that you are going to use it for at least 8 hours to 10 hours. And in case if you have the operations like 24 hours requirement as well, then you certainly need to design not only the envelope component but also the mechanical component based on the requirement itself. In case if you're designing the buildings which are hotel and hospital, then certainly the mechanical systems or electrical systems, they certainly be given more attention, because in during the operation, this is something which will cost you more in case if you have given not proper attention to these mechanical systems or electrical systems like HVAC, AC, transformer load, losses, and etc. All these components, they are equally important in terms of the designing of the envelope suitably. And the life cycle is really important, because you design the building for 50 years at least, and in case if you could maintain it, it certainly goes up to 75 or 90 or 100 years. And then when you look at the systems per se, all the electrical or mechanical systems, mechanical system, the highest efficient system in terms of centralized water cooled chiller system, the efficiency is one thing which is certainly should be higher, but the life cycle is also very much important. So the centralized air conditioning system may be able to give the required cooling for next 25 years, whereas the split ACs that can give or that can run only for 5 to 10 years. So that is something that is based on the building design and operational requirement of the building as well. And that is where I think the life cycle of each and every equipment, they need to be judged and they need to be analyzed, and the usage is the prime factor for the selection of the equipment as well. Now, when we look at the design strategy, and if you look at the right portion of the slide, you look at the envelope component first, then you talk about the lighting component, then comfort, which means the ventilation, either it is mechanical or natural, or in case if we have active cooling systems, then air conditioning system, then electrical component that covers renewable and the plug loads both. And this is how the series of interventions or the attention should be given, so that the building can be designed as net zero building. And this is how the typical example which is given in terms of the API reduction with the help of passive design intervention, then active, and then integration of the renewable energy component in the building as well. So when we look at the reduction of energy demand, which is which is bringing up down because of the architecture design. Because when you look at the building, it talks about the orientation and then different component like glass, roof, wall component design and their orientation, their placement, their size, and etc. All they play a very much important role in this. Then the material specifications, which certainly are important part, and along with the building technology, and they are component of the active interventions. And then whatever is the optimized number which is coming from, let's say, 192 EPI coming down to 50 or 45 EPI, then rest of the leftover should be or can be compensated by the renewable energy component. That is what I think a very simplistic process for the net zero energy building design. uh, Now, look at the minimum efficiency standard, which is there already in our country, which is named as Energy Consumption Building Code. We have 2007 Energy Consumption Building Code, which got launched in 2007. Then we have also seen the next version or the next launch of the code, which is the upgraded version, which is 2017. And in this version, the first part, which is the minimum efficiency standard, the second level that has been defined in this case, which is ECBC plus, and the third one is super ECBC component. From basic to plus to super, there is a additional 20% of the efficiency upgradation that we see in the efficiency standard. And that is where they have been defining the compliance mechanism as well, which is based on four component or sub component of the building. The first is building envelope, the second is mechanical system design efficiency standards, and the third one is the lighting and control systems, and the fourth one is electrical power and renewable energy systems. If we go to a bit more detail with the help of some of the examples, then we look at the envelope design consideration under the MEPS or minimum energy performance standards first. Then we certainly, as an architect, or even if we are not architect or understanding with respect to a normal human being, we surely understand that orientation plays an important role, because climatology, which is a part of the architecture curriculum, uh, teaches us that in case if you could orient your building in east or north non western facade or western oriented buildings, then certainly you will be avoiding a lot of heat ingress inside of your building, uh, particularly to the Indian uh, the climate or the geographical location specifically I'm talking about. Then when you have a certain orientation based on the climate conditions, then we certainly look at the material specifications and the size of the wall components in terms of windows, fenestration, shading, and so on. And that apparently has a lot of diversity as well. When we look at this particular slide, we have a couple of pictures. And if we look at first one, it looks more modern. And the second one is more like a conventional, but in terms of energy efficiency, both can apparently give the equivalent amount of efficiency in terms of the heat ingress, which is being allowed by the envelope section here. So, I, from the code perspective, it only refers the what is the U value of the component, what is the SHGC of the window glass, and what is let's say the VLT of the visible light transmittance, which is of the glazing component, and then for the envelope sections in terms of wall and roof assemblies, what is the insulation value which is being uh, implemented in the building to avoid the heat in gain from the external or ambient conditions. So that is where we see a lot of, let's say, a role and responsibility from the architecture or designer community side, because they are the one who design the building in terms of the envelope design first. And this is where we see a lot of, let's say, material which are, let's say, new, and they are also diversified and varied in terms of different location of the building. So if we look at this particular slide, it primarily refers the autoclaved aerated concrete block, and there are other materials also in terms of fly ash bricks. Sometimes we have also seen the a cavity wall as well. Then certainly a lot of other material and technologies which are available across Indian continent in terms of different type of material being used. So their U value or conductance value, they apparently an important role to play in terms of the energy efficiency component of the building. This is one of the buildings that we see here, how they have used the insulation material which is placed inside of the wall. In this particular case, I would like to mention that they have placed the insulation inside the wall, though the outside of the wall insulation will be more effective considering our latitude here in this location. But in terms of the planning component, which was already done, this was considered later. And then the inside of the wall is also equally good in terms of the interventions which have been brought in post design or wall construction there. So this is something which I wanted to highlight, that this is the way uh, should they should be implemented. So it is the wall component. Then you have a 45 thick insulation. This is XPS insulation, and then you have a gypsum board plaster, which can give you the very finished uh, surface for paint and other purposes as well. A lot of efficiency which is governed by the newer technologies, specifically glass. Glass is one of the technology which has transformed the buildings very, very much. And we have seen how different organizations have brought in the new technology with different kind of performance standards in terms of the normal glazing. Then you have different other glazings in terms of single glazed windows, high performance windows, then double glazed unit. Then also we have seen triple glazed unit also. Sometimes there are interventions which are technology interventions which basically led to optimize the VLT or visible light transmittance reduction as an inbuilt technology in the glazing itself. So this particular component is very very important, and because this is something which allows a lot of heat, but it also allows a lot of visible light inside of the component. So you just cannot avoid the glass in the building design. You have to optimize the glass. You have to use it carefully, and that is where I think the designer's role, along with the industry role, in terms of providing and facilitating the better knowledge and the better material together in this efficiency design of the envelope plays a role. When we look at the technology intervention through the material specific, I'm sure like the knowledge which is related to single glaze insulated glass, which can reduce the heat gain by up to 25%. And then certainly a lot of other technologies, as I mentioned, the triple glaze unit are also there. But in case if you could also look at the simplistic versions of the implementation, then SRI paint, which is also a part of the ICBC component, it also plays an important role. The best part is that it is a very easy to implement, and it is not only implementable for the new building, but also for all the existing buildings, roofs, which are available and they are exposed to the sun. They apparently help a lot in terms of uh, the habitants who are residing just below the roof slab there, and it reduces up to 4 to 5 degrees Celsius in the room temperature, which is the big savings for the air conditioning load in that sense. Apart from the heat, certainly daylight is in very much like equivalent or more important aspects that we look at from the building design and implementation perspective. And that is where we see the efficient glazing along with the shading design, they play an important role. The intent is to have not direct sun rays inside of the space for longer time, because in case if you have a lot of direct sun rays, then certainly it will be a kind of, let's say, um, visual discomfort for the user, because it acts like a glare, and then your working may have a certain disturbance. And that is where we see the glazing design, the shading design, they play an important role in terms of the building's comfort overall. This is one of the projects that we have done in 2012-13, and look at the Skylight design component, which is almost like 4.5% of the total building roof. And uh, you can look at almost like 15,000 to 18,000 square feet as a built up lobby area, which is lit from 6 a.m. till 6 p.m. in the evening, almost like 12 hours without any artificial lights on. And that is the beauty, and that is where we see the justification of having the design component with the appropriate glazing material usage, which can give a lot of comfort, certainly along with the optimized energy either efficiency or energy consumption for the building as well. From the code perspective, it pretty much like incorporates the UDI, useful daylight illuminance, in the buildings with different kinds of building category requirements. And we see almost like 10% for shopping complex to 40% in the offices and educational institutes. Um, and that is something which is very much important. And based on the ECBC or level, in case if we are going for net zero, we certainly need to target the maximum daylight inside the space. And that is where we see the design interventions along with the material playing an important role in designing of the best performing buildings. Then uh, the most vital component that comes to our mind is the air conditioning systems, comfort systems, and control. And that is where we see a lot of options are also available. not only in terms of active cooling systems, but also in terms of passive cooling systems, low energy cooling systems. There are very options available in terms of from the National Building Code perspective. It apparently refers the let's say natural ventilation process, and there are certain standards in terms of measurement of the comfort with respect to the air velocity and humidity and temperature. They are available. So a lot of buildings which we see, and they are very much like a beautiful building designed by the eminent architects. They perform very, very well without even air conditioning systems. But as of now, with a lot of constructions going on, we apparently look at the active and low energy cooling systems requirement as well. In terms of low energy cooling systems, there are several buildings which have been already available as a demonstration projects, and radiant cooling, geothermal cooling, and so many other systems which are there. Passive down draught cooling as an option also. And in terms of the active cooling based buildings, we look at the varied options in terms of the star labeling programs from Bureau of Energy Efficiency. It talks about the star labeling systems for the air conditioning systems. And then we look at the 1 star to 5 star in terms of, let's say, the lowest energy efficiency to the highest energy efficiency of the system. They are available. Then when we look at the higher, or maybe I think higher size of the equipment in terms of from uh, SPTACs to VRF, VRV air conditioning system, and from there to air cooled cooling systems to water cooled chiller machines or water cooled systems. Certainly, the COP or coefficient of performance or the efficiency of the systems, it gets improved, and that is where, based on the system design, building size, usage of the building, these systems can be selected. What I particularly means to say that in case if there is a particular room like meeting room which is not very often used, it means that you can apparently use the best efficient system which is not centralized, but maybe the 5 star rated SPTC can also be used instead of let's say uh, water cooled chilled system, which is also serving other component. Maybe is meeting rooms can be plugged with the SPTCs, which is not very regularly used space. So there are, let's say, the design interventions which are based on uh, uh, the detailing component, the attention given by the air conditioning system designer or the architect. They also play an important role to make the building net zero. What he specifically means to say that in case if a particular building which is, let's say, 1 lakh square feet as a built up space, maybe we can apparently avoid up to 50% of the built up space as a uh, maybe mechanically ventilated or naturally ventilated spaces rather than 100% space as a conditioned space. Now, if we have this matrix ready based on the usage of the space, I'm sure like this is something which is easily can be done because there are certain number of spaces which are typed or categorized as functional spaces, but they are circulation spaces primarily. They can be avoided in terms of giving the active cooling systems installed in those spaces, and that is where we can see the big savings can be achieved by just designing the spaces with a lot of carefulness and a lot of consciousness in terms of the achieving maximum efficient building as a goal. And that is where we see a lot of design intervention. Recently we also have seen the cooling prize initiative by Rocky Mountain Institute and supported by Department of Science and Technology here in India. They have also done a lot of newer technology based cooling system design which can apparently let's say consumes maybe one fifth of the total energy consumption compared to the conventional air conditioning system. So that is where a lot of technology interventions are also being advocated and being promoted, but there is a lot of interventions or design consciousness should be given and should be adopted by the designer community as well. Electrical power is a very much important component of the building in terms of attaining the building net zero, I would say. But the first and foremost statement from my side is that this is something which is a supply side of the equipment. So let's say it starts with the HT um, panel, and then goes to transformer, then goes to LT panel, and then the capacitor bank and other component which are a part of the distribution system. They apparently play an important role in terms of making the energy loss minimized. Because in case if your transformer is not giving an efficiency which is required for the system, I'm sure like from stepping down a stage, your energy loss starts, and then no matter what you do up to the building usage, your the losses are continued, and then your vision in terms of attaining the net zero will certainly be not as prompt or as attentive that it can be envisaged. So what I mean to say that supply side of the equipment in terms of voltage drop, in terms of load losses, capacitor bank, power factor corrections, all these things, they are an important aspects to look at, and along with that the power quality component, because the supply side of the equipment and the demand side of the equipment, all these component, they should be in sync. In case if there is any such a variation that gets happened, and there is a variation in terms of voltage drop, or the power quality is not up to the mark, certainly it will create an impact, or maybe I think the bad impact in terms of the life cycle of the demands of the equipment. So most important aspects in terms of the building design is also coming from the electrical power and renewable energy systems component of the code. So, and from the electrical power section, renewable energy is also equivalent or very equally important component mentioned in the code. As per the code, it says that 1% of the total connected load, or 25% of the total roof area which can accommodate the capacity of the renewable energy. Whatever is less in between these two components is mandatory from the code, and this is minimum efficiency standard requirement, which means it is mandatory. And then onward for the ECBC plus and super ECBC, certainly there is a more additional requirement from the renewable energy system side. So this is something which, if we look at the cumulative component, then we'll start with the envelope section, then we go to the air conditioning system, and then to lighting system, and certainly the electrical power as a last component of the efficiency standards. All four component, they cumulatively define the energy efficiency requirement for the building, and that is where we see the minimum efficiency standard governed by the ECBC code. But there's a lot more which are being done across the globe. Like let us look at this component as well. Now, when we look at the legislation component, certainly the activities have started almost like a decade before. European Union and United Kingdom, they have started incorporating the net zero energy building codes in their buildings, in, let's say, in case of residential, then public sector buildings, and so many different let's say countries, they have also adopted the policy, the vision in terms of making their built facilities as net zero. Certainly in terms of upcoming, they'll be defined and designed and as per the policy requirement as a net zero energy building. But in terms of the existing building stock, also to be converted as a net zero energy building. And that is something where we have seen a lot of countries have already taken up the initiative, and India is also has taken up the initiative. In terms of the first initiative was that they have impaneled six consultant from India. We are also one of the consultant who is impaneled as a net zero energy consulting firm with Bureau of Energy Efficiency. Secondly, they have also launched a program under which the 100 buildings can be designed or can be given as a technical assistance to the building owner and designer in terms of designing and converting the existing buildings as a net zero energy building. And that is where we see a lot of progressive path in terms of the policy, which is being done by Bureau of Efficiency in terms of adoption of net zero energy policy in terms of buildings as an industry. We see other examples as well around the globe. This is again the BCA Zero Energy Building, which is a very famous building in Singapore, which consumes as an API of 45, and then compensatory energy is being generated by the shading, by the renewable energy which is being installed on the shadings of the building, as you can see in this building facade as well. Then very famous building, NREL Research Support Facility, Colorado, USA. And this is a very, very efficient building which consumes less than 35 kBtu per feet square per year. And this is again one of the schools in Germany. And this is our own building, which is Andhra Paryavaran Bhavan, located in New Delhi. And MOEF and CPWD, they were involved in designing and implementation of the building. And this building has almost like 1 megawatt solar roof panel installed. You can see the panels which are projected outside also. It has almost like 1080 kilowatt peak as a capacity installed over the rooftop of this building. And this building is uh, performing almost like net zero or net positive building at this point of time. Then few more examples that we have seen, they are very much like performing and very much like uh, beautiful examples available. For example, this is Harera building in Panchkula. Is has one technology which gives a lot of let's say uh, cooling breather during the daytime of the operation of the building. In this slide, you can see this picture which shows the passive downdraft cooling feature. So during the operation of the day, after let's say 3 hours or 4 hour of the day operation, this uh, mist which comes out from the systems, and then it cools down the whole courtyard. And then from the courtyard, all the spaces which are part of the circulation spaces and some of the open ventilation spaces, they also get cooled because of this technology. And you can see uh, the let's say the covering which are basically by the solar PV panels. It also compensate in terms of optimizing the energy requirement for the building. This is one of the best building that we see in case of Punjab. This is again this is not in Punjab but in Haryana. This is again second building that we have seen. We were also involved in terms of designing the net zero energy building. It's also supported by Bureau of Energy Efficiency and USAID earlier. And this is UHBVN, Uttar Haryana Bijli Vitran Nigam. This is a Discoms building, so going for net zero, and the architect is DPAP. And this is one of a very favorite building which is very close to us. This is the Nalanda University project in Rajgir, Bihar. And this is where we also as a consulting firm is involved in terms of giving the technical assistance in terms of the green building rating certification for the whole campus. And this campus is going for net zero energy, net zero water, and net zero waste management during the operation as well. At this point of time also, during the construction of this campus, the campus utilizes the rainwater and it is not utilizing any single drop of the water from the municipality in terms of construction water requirement. And that is something which is very exceptional and unconventional approach that the project team has um, so far adopted in this case. With respect to the compliance approaches for the code, there are certain states like Andhra Pradesh and Uttarakhand and Uttar Pradesh and few more other states as well. They have also started asking for no objection certificate or compliance certificates from the architects and the owners in terms of the energy conservation building code compliance for the new building which is being sanctioned by the urban local body or municipality affairs department. And that is where we see a lot of let's say attention is being given by the designer community in terms of designing the building with at least minimum efficiency standard requirement. And then I'm sure like there's always a second step in terms of making the the efficiency standards more stringent and make the overall development towards as a net zero development as well. So this is the process that we can understand and advocate, and how it is useful to you as a designer or as a, let's say professionals working in the building efficiency or energy efficiency or construction domain. So if you have the task in terms of you are to go for let's say a new factory or the building design, or you have let's say existing factory or building which is going for net retrofit, then certainly the energy efficiency codes and standard you also need to look at the notification, because these standards are defined by the state let's say nodal agencies. Building is a state affair, so state requirements in terms of energy efficiency, they apparently play an important role. And that is where we see the state's energy efficiency codes and standard or the notification you need to go through and prepare the submittals and prepare the design intervention so that the minimum code compliances can be done. Certainly the higher standards is your voluntary requirement and maybe your choice in case if you want to develop something which is more efficient or net zero efficiency building uh, from your support. And then select the scope in terms of existing or new. Certainly, based on these two categories, there's a lot of design and the scope will be defined. Then set the target, whether we are going for minimum efficiency requirement or we are going for the highest level, which is the net zero energy building as a design. Then we look at the procurement stage in terms of tender stage, BOQ preparations, design, and then the empowerment of the consultant in terms of architect, green building, or the material procurement in terms of the vendors. They all are a very, very important role, because when you have set the target, I'm sure like material supply or the knowledge supply, they become inevitable component in terms of making your job easier. And then you go for the compliance certificate or recognition. There are a lot of let's say recognitions which are available from the state government, from the central government, from a lot of funding agencies uh, in terms of tax rebate, in terms of low interest rate loan available for such recognitions, and they must be utilized by the building owners. One of the example, and this is something which is very much important because it also gives a very unique picture in terms of even if you have not designed the building from the starting as a net zero, then what are the interventions which can be made available at the building level, or the material and the selection of the equipment level, so that you can apparently not be able to achieve, let's say, net zero, but at least you can achieve the minimum or let's say optimize energy efficiency requirement, which can give you these savings throughout the life of the building. This is one of the examples that I can show here, which is already built and it is operational. The performance is also being monitored of the building, and this is performing very, very well, maybe beyond what has been envisaged in this building. So this is based in Lucknow. This is almost like 55,000 square feet as a built-up area. This is a single tower or single building, composite climate conditions, normal office building. This is UP Electricity Regulatory Commission building. So this is typical office building, and this was the stage where when the owner of the building, they decided to go for the efficiency standard integration, and then they looked at energy consumption building code or rating systems and etc. In terms of integrating them and making the building more and more efficient. And you can see that almost let's say ground floor slab is being casted, and that is the best part or the worst part together, because they should have taken care of the energy efficiency or these interventions right at the design stage rather than waiting till the ground floor slab is getting casted. So but this is what it is. So this is something which is the summary of the option, and you look at the EPI, which is the base case, or the the energy conservation or energy performance of the building, which is defined as kilowatt hour per meter square per year. The conventional or base case standard was 125 as an EPI, and then in case of option one, this is 86, and with SPV, solar photovoltaic panel, a plant, this is 67. Then option 2 and option 3, they're also listed there. So you can look at this option, which basically 123 and goes to 67, which talks about almost like maybe I think 45 or 50 percentage uh, let's say energy reduction uh, based on such simplistic interventions which have been done in the building. And this also shows how uh, you can let's say intervene and implement the codes and standard, or making the building more efficient with the use of simple stepwise process in terms of energy conservation or energy efficiency integration. Then, in case of this is the conventional approach, this building was being designed with all the conventional building materials. Let's say wall was being constructed with the 230 brick wall, normal burnt clay brick, ET 150, normal glazing. It is not very normal, but this is certainly normal compared to the high performance glazing which are available in the market. Roof is 150 RCC roof slab, which is again the normal slab which we see. And these are the interventions that you can see in terms of the conductance improvement of the wall and roof. And this is where option one, in terms of outside plaster, then in external autoclaved aerated concrete a wall with 200 thickness. Then you have a cement plaster, and then you have a XPS extruded polystyrene insulation 50 thickness. I showed you one of the pictures of the insulation earlier, and that is where you could see how the conductance or the U value of the wall assembly, which is 0.305 watt per meter square per degree Kelvin, can be achieved. And similarly, there are other options, option 2 and option 3, with different ECMs. They also have been devised. Similarly, in case of roof, it also suggested under the option 1 that we need to use puff polyurethane foam as an insulation 50 thickness. And then you can see the roof U value is also bringing down to 0.36 watt per meter square per degree Kelvin. And similarly, option 2 and option 3. This is summarized a statement of all the ECMs being used in the building. So the wall and roof we have already seen. In case of glazing, we have used SKN 744. Then option 2 Planetherm, then option 3 is Envision, and option one which ultimately has been implemented in the building. We can see the HVAC, VRF, VRV as an option. Then we option two, radiant cooling. Option three is a chilled water system. And then lighting in all the options were being used. It's all LED lights with all occupancy and daylight control systems. They have been used in the building, because lighting is the most simplistic intervention, or ECM, which in any case we have seen the transformational changes and adoption across all the building types, including the residential and commercial and institutional as well. In case of renewable, they are also common implementation in all the options. 70 kilowatt as a peak solar photovoltaic panel, they have been installed over the rooftop, and the API was coming down from 123 to 67, which means that saving is almost like 50% compared to the baseline case standard. And this is something also includes the cost interventions in terms of cost implications over and above the base case. So in terms of ball in ECM, the additional cost was coming down to 26 lakhs. And in case of roof, it was coming as an additional cost impact was 6 lakh rupees. Glass, it was coming around 11.5 lakh rupees. Then we have VRF, VRV systems. The additional cost was coming uh, compared to 64 lakh in case of packaged unit earlier. VRF, VRV system was costing around 1.35 crores in the option one. Then in case of radiant cooling, it was coming around 2.4 crores. And in case of chilled water system, it was coming around 2.1 crore for the 55,000 square feet as a built up area. Then in case of lighting systems, 30 lakh rupees compared to 18.5 lakh rupees for the lighting interventions. Then you, let's say, occupancy sensors, again there is some cost like 1 lakh rupees plus. And then overall consumption, overall cost, and the extra cost was coming around 1.28 crore for option one. For option two, it was 2.24 crores. For red chill, for the option three, it was 2. Let's say 10 crore rupees. But the saving, which was coming around 27 or 28 lakh rupees over or compared to the base case, which was around 28 lakh. For option two, it was 25 lakh, 21 lakh for option 3. And that is how we can apparently decide it easily based on the payback time, which is, let's say, 4.6 years for option 1. And you could achieve 51% savings out of the simple interventions. And 4.6, which is, let's say, less than 5 years. We also assume, or maybe we can understand that in case if we could start the interventions from the beginning in terms of the design stage, I'm sure like the payback period could have been less than 3 years as well. So anything less than 3 year or 5 years, I believe that this is something which is worth spending in terms of getting the benefits for the rest of the 45 or 50 years throughout the operation of the building. And that is where we see the benefits of the codes and standard. But this is something which is the minimum efficiency standard integration or implementation. What we really feel that there is a lot more opportunities which are available in terms of let's say making the efficiency standards higher and making the buildings more like ACBC compliant building and net zero energy building to make them more efficient and make them more low carbon or no carbon development in times to come. So this is from my side in terms of low carbon smart buildings or net zero energy buildings as a presentation. I'll be very happy to answer a few questions if you have. Thank you so much. It was an Glass Academy for inviting me here.
Thank you for a very informative presentation, Architect Anurag. So the different case studies that you've shown definitely made us ponder on the many strategies that we should ideally be adopting and the amount of thought that would ideally need to go into designing such structures. So I have a couple of questions before we close.
Sure.
Does the construction process itself also play a role in classifying a building as a net zero energy building? Is it reflected in policy or as part of the energy conservation measures, or is it left to the designer's interpretation?
So I think construction process certainly is being defined by the construction material. So let's say, for example, in case if you use the RCC wall construction, then certainly being defined by the material itself. And in case if you use the let's say RCC column beam structure with the AC wall as a curtain, then certainly this is the conventional practice of construction as well. So construction techniques, you can always use it to make the let's say construction practices faster, and also maybe avoiding or reducing or optimizing the waste which comes out from the building site, which certainly uh, indirectly is a part of the energy optimization as well. This is something that, in my opinion, is important aspect, but there is no such correlation.
So to add to that, responsive site planning strategies themselves, while not reflected in policy, would you care to elaborate on a couple of things that you might have done to, you know, in,
So, in terms of the policy, it refers the minimum efficiency standards requirements. So, when we say standard requirement, it means that starts with the building design and goes to the construction, and then hand it over as a final product in terms of the building for the building users. In terms of the standards or the policy side, we look at the specifications, which is basically to be there in the building materials, to be there in terms of the building equipments. And from the policy side, they apparently talk about the building performance as a whole. So from the compliance approaches, either you go for the let's say minimum efficiency standard, or let's say prescriptive approach, or whole building performance approach. But in terms of the process of construction, you have been given a lot of flexibility from the policy side, that based on the geographic locations, based on your own resources, or anything which you want to use in terms of the innovation, you are free to include that in terms of building the building. But in terms of the performance, it should be governed by the codes and policies. But the process can be by can be anything.
all right. So in any of the projects that you were associated with, was the payback period a concern for the builders, or so how would you convince anyone who is not okay with spending more than 5 years on getting the actual payback?
So I think there are various kinds of let's say opinions and discussions which get happened in each and every project, I would say. So sometimes when the developer or the project owner develops the building for its own usage, then certainly they are more concerned for their payback period, because this is something which can give them a lot of operational efficiency in terms of electricity bill reduction or water use reduction and so on. Uh, but in terms of in a lot of cases, when the developer or the project owner is developing for the tenants, then I would not say there's that they don't concern at all, but there's a let's say limited concern for the payback period and making them more efficient. So whatever is the standard requirement in terms of the bylaws or from the policy requirement side, in terms of let's say minimum energy efficiency standards, they are following them because this is something that they have to do. But beyond that, I think a percentage is very less. I would not say that there is no one, but the percentage in terms of following and volunteering for the higher standards, they are very less, I would say.
Thank you so much for spending such a long time to explain all of this to us very in a very detailed manner. So any further questions that the other audience may have once this is put up on the website will be passed on to you, and then your responses will be uploaded there accordingly. Thank you
Perfect,
again.
Shruti. Thank you so much. Thank you so much, everyone, for inviting me here. Have a nice day. Stay safe and healthy. Thank you.